Hi, so here's a short video to begin with, video 1 on solving linear equations. So this is an example of a linear equation. It has x to the power of 1. When we are asked to solve a linear equation, it means we are finding the value of x that makes the equation true. I'll just write EQN for equation. So that makes the equation true. So that is what we're doing. So we're going to talk about solving linear equations. Now, in order to be able to do this, you need to be able to just remember what your inverse operations are. So for example, the opposite of addition is subtraction, and the opposite of multiplication is division. Okay, so we can think of these two as undoing each other, okay, or reversing whatever you have done. So for example, 2 times 3 is equal to 6, and 6 divided by 3 is equal to 2. So what we have done is we have reversed the operation here and here. So that is what is meant by inverse operations. So solving linear equations, then we're finding the value of x that makes the equation true using inverse operations. So that's an introduction. So now let's look at some examples. So one way that I've found is useful to explain to students in the past about solving linear equations using inverse operations is by the use of sort of like flowcharts. And so say, for example, our previous example of 2 times 3 is equal to 6, and 6 divided by 3 is equal to 2. Okay, so say we have an input of 2, and we are using a function machine, if you like. We're multiplying by 3, and out has come 6, so that is the output. So what we have to do, we're sort of like pretending, if you like, that we don't know what that is. What is the input? And so what we do is we work backwards. So 6, and then it becomes obvious to students that to work backwards, to get back to this original blue value here, that what we have to do is we must divide by 3 because it's the inverse to multiplication. So 6 divided by 3 is 2. Okay, so that's one example. So say, for example, if you had to solve the equation g plus 14 is equal to 24, and you want to solve the equation for g. Okay, so you can use this notation if you're not too sure. Obviously, for the more experienced people, there's no need, but it's just showing you from the beginning how it's working. This time, what we're doing is we're adding 14 onto g, and we have an output of 24. And once again, we want to know what g is, the blue missing value. So we work backwards, 24, and we are taking away the 14 to find out where we started from. So g is equal to 10. So we've solved the equation, g is equal to 10, and we've solved. Now finally, the nice thing about these is you can check your solution. So you have g plus 14 is equal to 24. You let your g is equal to 10. So 10 plus 14 is 24. Is that true? Yes. So you have solved it correctly. So you can check your answers to these equations? So let us look at another example now. So if you knew that b times 3 is equal to 30, you have to solve this equation for b. So you're finding what b is equal to. And this is a b, not a 6. Now, in algebra, we would not write b times 3. We would say 3b is equal to 30. So you've got your b, you're multiplying by 3, and the output is 30. So working backwards, you are now going to you're going to use the inverse operation. So that means divide by 3, and 30 divided by 3 is 10. So b is equal to 10. Then you can check. So let's check in blue. So is 3, this is the original equation. We've decided that b is equal to 10. Is 3 times 10 equal to 30? Yes. So the solution is correct. Okay, another example. So this time let's do a division and see how we write divisions in algebra. So say, for example, if we had v, our variable, our unknown is v this time. It can be anything. It doesn't have to be x. It can be any letter of the alphabet at all. So don't let that put you off. So our v, whatever it was, divided by 9 equals 6. Now in algebra, we often write that as v over 9 is equal to 6. That is going to be the more usual way that you would see it written. Okay, so our input is v. We are dividing by 9, and we are getting an output of 6. So we are going backwards. So the inverse, the reverse of dividing by 9 is multiplying by 9, and 9 times 6 is 54. So v is equal to 54. Check, always check. Is 54 divided by 9 is 6? Yes. Or we could say 54 divided by 9 is equal to 6, either way. Okay, so it's all about inverse operations. Okay, so now we're going to move on to two-step linear equations. So an example of a two-step linear equation is something like 3m plus 10 is equal to 37. So you have your input this time is m, and what you are doing is you're multiplying by 3 because you've got 3m, and then you're adding on 10. So 2 steps, and out has come 37. So you've got to go backwards. So this time you have 2 steps to undo. So 37 minus 10 is 27. And then the inverse of multiplying by 3 is dividing by 3. So out has come 9. So your value for m is equal to 9. And check. 3 times 9 plus 10, is it equal to 37? Yes. So this solution is true. So two-step linear equations, say it like a sentence in your head. 3 times m, so I'm multiplying m by 3, and then I'm adding on 10, and I'm getting to 37. So I'm working backwards from 37. So I'm going to undo addition by 10, and I'm going to undo multiplication by 3. Okay, so that's just a two-step linear equation. Okay, so here's an example of another two-step equation. T over 4, or t divided by 4, minus 2 is equal to 15. We have to solve. We have to find what t is equal to make this equation true. So our input is t. The first thing we are doing is dividing by 4. T over 4 means t divided by 4, remember. Then we are subtracting 2, and the value that we arrive at is 15. So we're going to go backwards. So the inverse of subtraction of 2 is addition of 2. So this time you're going to get 17. And then the inverse of division by 4 is multiplication by 4. So 17 times 4 is 68. So T is equal to 68. Check. Is 68 divided by 4 minus 2 equal to 15? Yes, it is. 68 divided by 4 is 34 divided by 2, which is 17, minus 2 is 15. So T is equal to 68. Now, for some reason, people tend not to do, just let me highlight what I mean. They tend not to reverse this correctly. So they get to here and then just do division by 4 for some reason. So, you know, always remember to use the inverse operation. So on the next slide, what I'm going to do is I'm going to write some questions for you to have a go at, and you can pause and have a go and try them, and I will put the answers on, and then that will be the end of this first video. Okay, so here are a few questions for you to try, 4 questions for you to try. So pause the video and have a go, and then come back and check your answers. Okay, so for question 1 then, you've got 5y minus 12 is equal to 33, so therefore 5y must equal to 45, so y is equal to 9. 10m minus 26 is equal to 44, so 10m is equal to 44, 64, 70, so m is equal to 7. So here 5y would be equal to 45, so just in case the working is there. Okay, so here x over 4 equals 12 minus 8, which is 4, so x is equal to 1, and 8h plus 9, so take away the 9, so 8h is equal to 64, so h is equal to 8, because 8 8s are 64. So check your answers, check each one, remember, which would be good exam practice to make sure that if you've got the time, that is. Okay, so that's the first video on solving linear equations using one-step equations, two-step equations, inverse operations, different letters. So you can see it's not always X, it can be any letter. And I hope that you've got on well with this. Thank you very much.